Okay, it's top of the hour and we're up to our final presentation before lunch. I'd like to welcome you all to the Terminology Leading Practices stream of the SNOMED CT Expo for 2024. I want to thank B2I for sponsoring this stream. I'm Kathy Richardson. I'm one of the senior terminologists in the content team at SNOMED International, and I'm your moderator for this session. Now, the presenters have raised that they're happy for questions during this presentation. So for those in the room, please put your hand up if you don't understand something or you've got a question along the way. So the microphone, and you guys can manage that. They've both got my spare microphones. Online attendees, if you use the Q&A button to type your questions, I'll watch out for them. Now, I'm now pleased to introduce Anna Rossander and Daniel Carson, who will be presenting terminology binding to bridge differences in information structure. Please go ahead.
Oh, hi and welcome everyone. So I'm Anna Rossander. I work at one of the healthcare regions in Sweden. I'm also pursuing a PhD at the Karolinska Institute.
And my name is Daniel Carlson. I work at the Swedish eHealth Agency, but that is in Sweden. And I'm also happens to be one of the co-supervisors of Anna for her PhD studies. So.
So the main question for this study is, I think, what we are all sometimes wondering about: how can we reach interoperability between different systems, places, people? And we were thinking maybe if you terminology bind to an ontology with description logic or defined ontology, that could overbridge the differences that we know that we have in templates or information structures or whichever format we use to enter our information. So that's the question that we're trying to answer with this work.
But first, some background information for those of you who are new to this area. Terminology binding, we put up a definition here. So terminology binding, that's the process of getting the link between the terminology and elements in an information structure. Like, and the terminology could be something like SNOMED, and an information model could be something like FHIR or whatever you are using. This is the overall definition, but we'll go into some more detail when it comes to terminology binding with an example. So there are a number of different cases of or types of terminology binding. So we will look first at something called value set binding. And the case here is that you have a data element in your structure, like here we have allergies, and then you know that I want to record allergies to nuts, apples, egg, and guinea pigs. That's our use case for today. And with that, we could apply something called value set binding. So by going into the terminology, and our terminology of choice is of course SNOMED CT, we could find a subset of SNOMED codes that would meet the requirements that we have in this use case. So we have, like you could read there, you might be remember those from previous animation. So that is called subset development, and then we take that subset and we bind that to this, like the data element on allergies, which is a coded data element. We bind that and we call that value set binding. But there is yet another kind of binding called, like we call that meaning binding. That is when you have done your value set binding, you might also want to bind, so what was the question about? You might want to query for, like, where is this question in my EHR, where is this question posed? This is called meaning binding, and that's where you bind to the actual question, the data element itself, not the values of the element. So here, for example, we bind that to allergic condition, which is a finding that's questionable, but let's not get into those details just now.
It could have been an observable.
It could have preferably been an observable, but I don't know if that exists, so we had to pick something. Anyway, then we immediately in practical cases run into problems, because as you who are all like various levels of SNOMED experts here in the room know that there are both a substance hierarchy and a finding hierarchy, and there are like a pattern for how to represent allergies in SNOMED. So for example, we have allergy to nut, which is a SNOMED concept. It's a finding, but that could also be represented by two concepts. So like allergy condition and the substance to which you're the allergen, the substance to which you are. And like this is like a question like how long is a rope, or like it's will depend on a lot of, like, it could be data entry requirements, it could be reuse requirements, it could be like whatever technical implementation you have that would govern. It could be a number of different aspects that like would make you consider which of these approaches you would use. And this is called the boundary problem. Like where do you draw the line between the terminology and the information system there?
So what we did was that we found two different projects ongoing who had chosen to solve this boundary problem. Well, we didn't know that, but we guessed that they would have solved the boundary problem in two different ways, because most people do. So we took these two as material for the work. So I'll just briefly explain what they are. One is the ICCR cancer reporting forms. You've heard of these, I assume. It's been the ongoing work for a working group here, the Cancer Synoptic Working Group, for several years. So it's not the ICCR that's done the work. It's just that these are the templates that we've used. They look like this. They're Word or PDF documents. And the working group has terminology bound these to SNOMED CT and also developed a lot of new content to do that. They have also produced a fire questionnaire, and this is the material that we used as input for the study, the actual JSON file for the fire questionnaire. And we've picked the SNOMED codes from that to see what codes or what concepts have they used. So the other material is work done, whoops, did I do that? Is work done by a Swedish group, the Swedish Society of Pathology. They have also sort of spontaneously in parallel started doing work on breast cancer reporting. They've had a different approach. I mean, they've also started from some sort of background material. This is a Word document. This is in Swedish, but it's free text description of what they want the pathologist to report. So it's similar to the Word template I showed you previously. But the Swedish group has done a different approach. They have developed workflow models. They have developed concept models of everything included in the report. They've made their own information model. And then they finally developed OpenEHR templates and archetypes in the other order, I think. There was no international archetype when they started, which surprised them. So they've been working on that, and they've done the template, and they terminology bound it to SNOMED CT. So this is what we've used from their group, the terminology bound template as input material.
So some words about the method used. When we found these two sources, I think that is an opportunity for research whenever you have two groups who worked on a similar area and like independently, to be able to see what are the differences, what can be done to bridge these differences. And like they were not completely the same scope. So some of those were like lymph nodes was in the Swedish, but not in the international, because that was in another document and so on. But there was a core that was fairly large, which was like where there was an identical scope. So we should expect at least to find the same kinds of data in these sources. And then because these were both bound to SNOMED, we could expect to use like the technologies that SNOMED allows. But first, we broke the rule that says that you cannot use Excel for anything else than your household budget, and I'm quoting Ronald here, I think, who formalized that rule. But we did because we first needed to get the overview. What are these data sets looking at like? So we took the two data sets, we put them next to each other in this wonderful tool, and used color markings and whatever to allow this. And that is basically what this exercise that we are reporting now is based on. Thank you.
So some of the results, I think maybe you would want like a quantitative answer. How much identical concepts were there? So we can report that, and then we'll discuss if that's an interesting question or not. But this is per concept. So if you remember the Excel sheet, there were like questions and then there were answers. So there were rows. And as you can see, 2 out of 3 of those rows were actually identical concepts. The concepts IDs were identical. But that is including questions and then answers. And some questions can have 10, maybe 20 answers. But if the question is differently posed, then maybe that identical answer shouldn't be counted as equal, you see, because it won't be, you can't transfer it 1 to 1 anyway. So if we instead look at only the question, it becomes less nice because only 1 out of 4 questions use the same concept on both structures. This is a rough estimation, but we just want to show you that it's even though the information per se is identical, the choice of concept is not in most of the cases.
So let's look at one example where we saw a difference that was frequently occurring between the two data sets, and that was the amount of pre-coordination applied in the SNOMED concept. So on the one side, on the left side, we see a concept from the ICCR work, and on the right-hand side, we see an example from the Swedish work. And like in this instance, this is the whether there were tumor at the side of the margin in the specimen. We saw a lot more pre-coordination on the side of the ICCR. But we also found that there is actually an ISA relationship between these two. So the ICCR concept is actually two ISA levels down compared to the concept selected by the Swedes. If we look into the details, and this is the this analysis requires some insight into the observers model, which happily I am somewhat familiar with. But you could see that there are differences, at least in 4 different places. But there are 3 different aspects that differ. So one is because this was for breast carcinoma, you could see specimen obtained from breast obtained by excision, and on the right-hand side you see just tissue specimen obtained by excision. So there's no specification of the organ on the Swedish side. So that's one difference. The other difference is the presence of primarily malignant neoplasm. So on the Swedish side, it's neither necessarily primary or a malignant neoplasm. It's just whatever neoplasm is found at the margin. And so there are those 3, it's the organ system, whether it's primary or secondary is unstated, and whether it's malignant or not. That was assumed in the Swedish case to be not known when you're looking at the specimen. This might indicate that there are actually different stages in the process, that these are, so might not actually be comparable, but it's like it would require further analysis to know what was the case. Can this be bridged? Yes, it can. That's interestingly, but it's actually fairly complex. The breast structure aspect of this could be that is in the context of the Swedish, it's invasive breast carcinoma protocol. So that could be like added to the context, but it would have to be added into the nested structure of the specimen. You see there is like inherent location that could be added. So it could be done, the primary and so on, it would require some more work and analysis if it's really the case in the Swedish version. It can be done, but it's actually fairly complex, and assuming that the systems that we use are developed with the speed that we've seen so far, it might be unrealistic to assume that systems would implement that kind of functionality in the near future.
So this is another example of two concepts for the same meaning that are modeled differently. The right-hand concept is new and made in the Swedish extension. That's why it has this little Swedish flag on it. And that's also why all of the attribute values are in Swedish. So these are used to capture the same information, but they're different, and they also have differences. It's the primary, just as the previous one. It's the breast. This, the left-hand side concept also has the word qualitative in the FSN, which the right-hand one does not. We're not really sure what that means, and it's not part of the attributes. So we don't know. These are not like in the same branch. So to go between these in the hierarchy, you would have to go 3 up. That's what it says on the top right side of the slide. You would have to go 3 up and then 1 down. So they're not, I mean, they're like siblings, cousins or distant cousins or something like that. So these are not so easily translatable as the previous example. You might ask now, why did you make a new concept? And it's because the Swedish pathologists, they looked at the left-hand side concept and said, well, that's not true. That's not what we're documenting. They wouldn't want to use this. So that's why we did that. But obviously, there is a balance between getting exactly the concept that you like and using the same concept as everybody else. We had that discussion for some time.
Another difference is like other, the idea of other, which you put in the end of all your selection lists. So like you have the list of stuff, and then you have anything else. You add up a thing for anything else on your list to allow the flexibility that is needed in all practical, I think, use cases. So, but there were different approaches used, and both used SNOMED to represent other. There are also like you could do the FIRE or HL7 way of using another completely different code system. But these use different. So you see, for example, on the ICCR side, there is the it said not specified, and they used the not recorded concept. The Swedish side used another strategy that would to use a concept that is subsuming all the other concepts on the checklist. So that would still cover the same like meaning, but it's not specified at all. It would at least it would give a hint of what the meaning of that other concept is, but it's without any details, and that's the idea of other, is that you do not provide the details. But there are just different strategies, and they're not like you would have to know in order to map these. That was the intended meaning of those.
Yeah. And then there's a final result that we've noticed, and this was not part of the main question, which was about if the concepts were identical, but we noticed, and you can see that on the previous slide, the top 2 concepts on the right and left-hand side are the same concept IDs, the same FSNs. The wording above is what is shown, the display term. So one of them have chosen operative procedure performed. The other one, I've translated it, but basically it says specimen from. These are pretty similar. I agree, but we've seen other examples in the material where the display terms have been slightly different, and they've been slightly different in different directions. So that means that 2 people will be documenting something in 2 different forms. They will be reading a term, and both of them will be connected to the same concept ID on the backside. but they've not seen that FSN or preferred term. They've seen a local display term. And this was very common. The ICCR uses only their own display terms, no SNOMED CT descriptions at all. In the Swedish material, there were approximately 1 out of 10 of the display terms were descriptions, and those were for the new concepts, where we actually also made the descriptions that the clinicians wanted. But when we used existing content, they said 100% of the times they said the preferred term is not good for us, we want this instead. So this is a BIFIN, the secondary finding in the material, and it might be worth thinking about that even if you have the same concept ID, if you have shown a different display term, you might have a problem with the information there.
So discussion. So the conclusions are like, there are some cases where there is actually a one-to-one relationship between the two results of the work. And then it could be straightforward to do transformation between the two. But those are unfortunately rare.
Well, and then that's just what I said, that if you have a local display term, it introduces a risk. You have to be aware of that.
Yeah. Everything else is like ranges from difficult to impossible, I would say. Or like that would require specific mapping work between two different solutions in the so while we did find examples where you could actually, we showed the example before, where you could actually use a SNOMED concept model to map between the different solutions, like using the different attributes of the observables model, for example. But it would require a quite extensive work to do that.
And then there are ones with the other example,
Yeah.
which with the concept model won't help you. You would have to have, I'd say at least today, you would have to have a human looking at the template forms and understanding, okay, this is what they mean here and there. So that will be the rarely possible. Yeah. And then we noticed that the existing content in the browser, because the ICCR project group was earlier time-wise, much of the new content is modeled by them. So it's closer to their forms than to the Swedish form. Yeah.
So,
guys, you didn't ask any questions.
Yeah.
Well, let's start with a thank you and then we'll move on to questions. So thank you, Anna and Daniel. Okay, the two presenters have microphones. So if you have any questions, pop your hand up. Oh, there we go.
Thank you for very interesting talk. I think you've made a problem very clear. Do you also see some way to addressing these problems?
Well, there was this context management group yesterday. There are several different ways to address the problem, and maybe that's the problem itself, that it would be nice maybe if we chose a few of those ways, maybe one of those ways. For the parts where we have different concepts, but they're within the same hierarchy, I think developing tooling that can help us move between up and down the hierarchies, that would be a solution. For the problems where we've chosen different ways of solving we have to agree. And maybe we have to choose one way, even though that's hard.
So first, I think, so like we were looking into the fairly complex, at least somewhat complex clinical domain. There might be other domains that we can look at. I'm thinking about maybe looking at specimen to pick a random example. Would be maybe more straightforward, and we could do the analysis again and see if we fare better. That would be the one. The other one, like this needs also we have to work with the clinical, maybe the Swedish feedback, why they didn't like the ICCR protocol and why that didn't work. There could be feedback, and there could be on the clinical side, there could be development of these models where we could reach more of a global agreement. It also collaboration in the like information modeling space, like with other standards organization in trying to get a larger agreement. And maybe we like it's about pushing the problem to become like I think that it's unrealistic that we will ever get away from the boundary problem, but we might be able to push it into more like friendly areas where they're easier to manage over time.
Mm.
Thank you.
Mm.
Excellent question.
Any other questions in the room? Okay, there are no questions online, but I have got one here. How do you think SNOMED International, the SNOMED community, can support or alleviate the alignment ideas on working together?
Yeah. So I think that like the SNOMED community is already doing this. I think the work on like the cancer synoptic reporting is a good example, even though we didn't like get there this time. I think it's still a very like at least for those of you who doesn't know, there is an implementation guide for cancer synoptic reporting that has been developed by the SNOMED Cancer Synoptic Reporting Group. There is one developed for allergies, so there is an allergy implementing guide. I think this is really something that is like two very good examples of how the community is addressing this problem and collaborating with other standards development organizations. Like there are more examples, like IPS would be an obvious example also where there is good collaboration. So I think more of that, looking at how can we support actual implementation to make them more consistent. So that I think that's Anna.
Can I just, we discussed this previously, and I think what we also said was that we can't, as informaticians, we cannot take the sole responsibility for the interoperability issue. We have to push, I think maybe that was what you meant with the friendly space, but we have to push it towards the clinicians. So these implementation guides are a good example, and maybe the problem here is that the Swedish group didn't know that this was going on. They were unaware, so they did their own work. Maybe if they would have instead joined, then we would have had a tighter agreement between the two different groups.
Thank you. Okay, we're coming up to the top of the half hour, so we're going to conclude this block of sessions. So thank you very much, Daniel and Anna. Okay. So